In this video, we're going to briefly introduce the concept of colligative properties. So a colligative property is a property which depends only on the number of solute particles in a dilute solution and not on their kind. So some examples of colligative properties that we're going to discuss include things like freezing point depression. So if you take a solution and then you add in, or if you take a liquid and then you add in some solute in a very dilute concentration, the freezing point of that liquid will decrease. It will go down. And the more solute particles you put in, assuming that you're still under the limits of a dilute solution, the more particles you put in, the lower that freezing point gets. And it doesn't matter what kind of particles these are. So these could be glucose, sucrose, fructose, could be something that's not a sugar at all, could be any kind of thing as long as it's the same number of particles. So if I put in 0.1 moles of particle X or 0.1 moles of particle Y in water, the freezing point of water decreases by the same amount. If I put 0.1 moles of something in, I don't know, hexane, and I put 0.1 moles of something else in hexane, the freezing point of hexane decreases by the same amount in each case. Okay, and then another one we can talk about is boiling point elevation. So just as the freezing point for a given liquid will go down when you include particles in a dilute solution of it, the boiling point will go up. So if you add some solute to water, the boiling point of water will go up. If you add the same amount of a different kind of solute to water, the boiling point will go up by the exact same amount. And each different liquid will have a characteristic value for how much its its freezing point or boiling point go down or up, depending on how much you put in there. And the last one, which we'll discuss, is going to be osmotic pressure. And osmotic pressure similarly has to deal with exactly how particles of water flow through a semi-permeable membrane and act to dilute a given solution, and there's a pressure that results because of this, because there's an imbalance of chemical potential on both sides. But more on that later. So each of these obeys some nice empirical laws. If we talk about, for example, the depression of a freezing point, so delta T fuse, the amount by which the freezing point of a liquid changes in a dilute solution, is equal to the minus freezing point depression coefficient times the molality of the solute. We have, and that's going to go down. I have this minus sign here to indicate that this Kf is a positive value, molality is a positive value, so putting a negative sign in there, the freezing point is going to go down. For the boiling point elevation, that's going to go up by some value, and again, that's going to be a nice linear relationship. You're going to have the boiling point is going to elevate by the boiling point elevation constant times the molality. And osmotic pressure, which we're going to define as pi, which is the pressure that's going to result on different sides of a semi-permeable membrane, that is equal to the concentration of the solute on one side times the gas constant times temperature. So that pressure is going to increase with temperature, but it's also going to increase linearly with the concentration of whatever solute it is. So the molality of whatever solute this is increases the boiling point by the same amount. This Kb and Kf are dependent on what particular solvent you have, and we're going to derive in the next video how we get what the value of Kf and Kb are. And then the video afterwards, we're going to look at the osmotic pressure and see what it is why the osmotic pressure develops and exactly why it is proportional to concentration as well.